Do you think strings are just for writing messages like "Hello World"? Well, think again. In scientific computing, Python strings are way more than just text. They're actually iterables, meaning you can loop over them, character by character. And trust me, this property turns out to be surprisingly useful in sciences, including chemistry. But before we dive into scientific applications, let's get comfy with the basics of strings as iterables. Ready? Let's go. In Python, each character is considered an element of a string, no matter how many bytes it takes up in memory. Take this string. My string equals chemcafe. Indexing. Remember, Python is zero-based. That means indexing starts at 0. My string 0 gives C. My string 1 gives H. My string 4 gives the blank space. Yep, even blank spaces count. And hey, negative indices exist too. Index -1 is the last element, and index -2 is the second last one, etc. My string -1 gives A, that fancy French accent E, and my string -2 gives F. So yes, Python lets you grab characters from both ends. It's like chemistry. Sometimes you look at the molecule from the left, sometimes from the right. Length. To get the length of a string, we use len. Len of my string. This gives us 9. Why? Because even that blank space counts as 1. Now, quick comparison. In C++, things get tricky. Elements of standard string are bytes, not characters. So non-ASCII characters like A may take up more than 1 byte. Check this out. std string my string of chemcafe. std cout my string length. C++ gives 10. So Python says 9, C++ says 10. Immutability. Strings in Python are immutable. That means once created, you can't change them directly. Try this. My string 4 equals S. Boom! You get the message, type error, stir object does not support item assignment. This immutability is intentional. It prevents accidental modifications and allows internal optimizations. And in science applications, this safety and performance are super important. Think of it like a lab safety rule. You don't just swap chemicals mid-reaction. Iteration methods. Now the fun part. Iterating over strings. Since strings are iterables, we can loop through them in different ways. Let's explore. Method 1. Using range and index. For st in range len of my string, print my string st end equals blank space. Output chem blank space caf a French accent. Classic method, like checking each atom in a molecule one by one. Method 2. While loop. idx equals 0. While idx less than len of my string, print my string idx end equals blank space idx plus equals 1. Output chem blank space caf a. Here, you're the one incrementing the index manually. It's like titration. You keep adding drop by drop until you're done. Method 3. For loop without index. For s in my string, print s end equals blank space. Output chem blank space caf a. This is the cleanest way. Just let Python handle it. Less stress, more coffee. Method 4. For loop with enumerate. For idx ch in enumerate my string, print ch end equals blank space. Output chem blank space caf a. Enumerate is like having a lab assistant who not only hands you the sample, but also labels it with the index. Super handy. Now print both index and character. For idx ch in enumerate my string, print idx, ch, end equals, comma, blank space. Output 0, C, comma, 1, H, comma, etc. See, you get both the index and the character. It's like a periodic table, element plus its atomic number. Method 5, while loop with enumerate. Now, enumerate is designed for for loops, but what if you really want to use it in a while loop? You can, but you'll need next function. Enum iterator equals enumerate myString, while true, try, idx, ch equals next, enum iterator, print fstring, idx, ch, except stop iteration, break. Output 0, C, 1, H, etc. Here's what's happening. Enumerate myString creates an enumerator object, while true starts an infinite loop. Next, enum iterator fetches the next index, character pair. When no more items are left, Python raises stop iteration. We catch that exception and break the loop. Basically, you're manually doing what the for loop does automatically. It's like washing lab glassware by hand instead of using the dishwasher. Possible, but why? So, to recap, strings in Python are iterable, immutable, and super flexible. You can index them, measure their length, and loop through them in multiple ways. And while this may seem basic, these properties are the foundation for how strings are used in scientific computing, including chemistry applications we'll explore next. In the next part, we'll see how strings can actually help us in real scientific problems. Spoiler, they're not just for saying, "Hello world." But before we jump into molecules and DNA, let's take a detour into some miscellaneous string functions that are incredibly handy. Let's start with a simple string. String CCC equals CCC. Notice the mix of uppercase and lowercase. 1. Uppercase and lowercase. String CCC equals string CCC dot upper. Print string CCC. That prints CCC, all capital letters. Print string CCC dot lower. That prints CCC, all lowercase letters. With upper and lower, you can shout or whisper in Python. 2. Joining characters. String single equals dash dot join string CCC. Print string single gives C dash C dash C. Here, join inserts a separator between characters. You can use any separator, even long strings. It's like building bonds between atoms. 3. Replacing substrings. String double equals string single dot replace dash, equals. Print string double, which gives C equals C equals C. Now we've replaced single bonds with double bonds. Voila! Carbon chain with double bonds. Organic chemists rejoice. 4. Counting occurrences. Print string double dot count equals gives 2. Print string double dot count dash gives 0. Counting bonds is as easy as count. No need to balance equations by hand. 5. Finding substrings. Print string double dot find C equals gives 0. Print string double dot find equals C gives 1. Dot find tells you where a substring first appears, like locating functional groups in a molecule. 6. Alphabetic check. Let string methane equals CH4. Print string methane dot isalpha gives false. Print string methane 0 dot isalpha gives true. Print string methane 2 dot isalpha gives false. Dot isalpha checks if characters are letters. In CH4, the 4 ruins the party, but checking individually shows which are atoms and which are numbers. 7. Digit check. Print string methane 2 dot isdigit gives true. Dot isdigit does the opposite, spotting numbers, perfect for identifying atom counts in formulas. 8. String multiplication. Let string ray equals dash ray and construct a new string as string multi equals x times 3 plus string ray. Print string multi, it'll show you triple x-ray. A PG-18 string! Print 4 times xy. That prints xy, 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 xy. Yes, you can multiply strings. It's like polymerization, repeating units over and over, and sometimes it makes for dark humor, like triple X-ray. Don't worry, it's safe for chemists. All right, that's our quick tour of miscellaneous string functions. With these tools, you can transform, search, count, and even multiply strings. And now, with both the basics and these functions under your belt, you're ready to see how strings can be applied directly to science. I'll be seeing you.
I'll be coding you in all the new upcoming tutorials I do on Python scripts for chemistry labs.